This conference will now be recorded.
Good evening all. Today we are discussing about clusters. What is a cluster? Cluster is a storage area. First of all, cluster is a storage area. What is the use of cluster? Suppose if you have related data, all related data saved at one place. All related data saved at one place, one physical disk space. In future, if you write any join query, then join data is selected from one place. Then it is reducing your data search time. So if you want to reduce the execution time of join query, you need to create a cluster. Again, I am repeating, what is cluster? Cluster is a physical disk space. What is the use of that disk space? I can save related information, means employee data corresponding department data, product data corresponding company data. Related information we will save at one place. In future, if you write any join query based on that data, then your join query execution time is reduced. Why? Because it will select related data from one physical storage area instead of selecting data from multiple physical storages. According to business, EMP and DEPT, both tables compulsory related with each other. Why? Because without department, there is no employee, and every employee should works under a department. Both are related. Let us assume cluster not created, tables created individually. Tables not created in a cluster. Simple example, tables not created in a cluster. Then what will happen? Maybe department table data saved under one data block. Employee table data saved under other data block. Department table under one data block. Employee table data under another data block. So this is called as non-clustered tables. So the related data is available apart, means the related data not available from single data block. It is available from multiple data blocks. If it is available from multiple data blocks, in future if you write a join query on EMP and DEPT tables, then join query fetch data from multiple data blocks. It will take more time. Instead of this process, if I create a cluster, in this cluster, if we create department and employee tables, listen carefully. First, we are creating cluster. In that cluster, we are creating employee table and we are creating department table. Then what is the effect of cluster? See, department table is parent. First parent created. Okay. And parent records are there. This is 10th department. This is 20th department. Listen carefully. First parent created. Next I am creating child EMP table. and I am inserting employee table data. Suppose if a record inserted, if employee inserting, the employee working under 10th department, automatically the 10th department employee record saved under 10th department automatically. You can easily see this is employee table, actually right side table, employee table. Who are working under, who is working under 10th department? Smith, Jones, Watt. So in future, if you insert those records, 10th department employees automatically arranged under 10th department record. And see, employee number, employee name, we don't have department number here. Why? Because it is not necessary to identify record. Already records arranged under 10th department. So ultimately these employees working under 10th department. Hope you understand. Similarly, 20th department admin. So here, Care, Wilson, Norman. Yeah, Care, Wilson, Norman. So if you insert those three records, that three records are automatically arranged under 20th department. Understand? The related records automatically arranged under corresponding parent record. Related child records automatically saved under corresponding parent record. So in future, okay, cluster created, tables created, data inserted. In future, see, all these data available under how many data blocks? One data block. Here, two data blocks. So one data block means, in case if you write join query on EMP and DEPT tables, then related data is fetched from single data block instead of multiple data blocks. So cluster is saving your join query execution time. This is the benefit of cluster. And now come to this point. What is a cluster? Cluster is a storage area. That is, okay, hold on. Cluster is a storage area. Physical storage area. Physical storage area. Okay. That is shared by group of tables. That is shared by group of tables. This is called as cluster. Then what will happen? Hold on. Yes, I'm getting it. Okay. Here, so what is the meaning of a group of tables sharing same area? All the related table records are physically stored together. This is the benefit of cluster. Okay. So at what time we will create a cluster? Cluster creation is recommended if you write a query based on two tables again and again. Means you are writing join queries on the tables again and again, and those tables are related or joined with a single column. Means EMP DAPT. What is common column? Department number. Product company. Common column, company ID. So like that, if two or more tables joined together with a single column, with a single common column, and most of the times you are raising join query on those tables. In both these cases, we will create clusters. What is the advantage? It will reduce disk IO and it is decreasing join query execution. And also here see, if there is no cluster, common column is appearing 2 times. Without cluster, with the cluster, common column value is storing only 1 time. That is also one of the benefit. Reducing disk IO and increasing join query execution speed, and also cluster key value is saved or stored only once. Okay, now again I am repeating, what is a cluster? It is a physical storage area that is shared by group of tables. And then see, what is the meaning of that? Means related table records are physically stored together. If they store it together, in future if you access from that place, the join data is selected as much as fast. Now, how to create a cluster? If you want to create a cluster, you need to follow 3 steps. First one, create cluster based on common column. Create cluster based on common column, compulsory. Second one, create index on the cluster. Create index on the cluster. Next, create tables in the cluster. Create tables in the cluster. We should create like this. Here, how to create a cluster? See, create cluster, cluster name. This is common column name, data type and size. Now, create the tables. See, we know how to create a table. We know how to create a table. So create table, table name. This is parent table. Department number. It's a primary key compulsory. Name, location. Here compulsory specify primary key. Constraint PK department number under DEPT5 table. DEPT5 table primary key. Why? Because you created cluster based on common column. So name of the department, location of the department. See, after column definitions, you should specify this cluster, cluster name, common column name, because this table is created under this cluster. This table created under this cluster. Next, similarly, create a table, child table, employee, EMP5. Just I'm creating employee number, name, salary, department number. You should define foreign key on this. Constraint FK, department number on the table EMP5, foreign key on department number, references from parent table DEPT5 and the common column DEPTN. And at the end of the table, compulsory specify cluster, cluster name, common column name. So let me create. What is cluster? Cluster is a storage area. Why is cluster? We can store related tables under one cluster. Benefit: related data automatically stored together. physically. Advantage: in future you can select join data from related tables. Then join data is selected as much as fast. Now let me create cluster. First create cluster, next create index, next create tables. How to create cluster? Before that, let me select the data. Table names. Select table name from user underscore tables. So many tables are there. Here EMP1, DAPT1 tables not there. Okay. Now create cluster to store EMP1 and DAPT1 table data together. How to create? Create cluster. EMP-DAPT is the cluster. Common column department ID number of 2. That's all. In the EMP1 and DAPT1, we want to maintain a common column DID. Cluster created. Now create index on the cluster. So create index IDX on EMP-DAPT cluster on which cluster? EMP-DAPT. What is on EMP-DAPT? No. Hold on. Here we have data. On cluster. Okay, cluster keyword we are missing. Yes. See, create index, index name on cluster EMP-DAPT. That's all. Cluster is created. So first first cluster created, next you are creating index on the cluster. So here you are creating index on cluster. So that index is called as clustered index. Clustered index. Next, create parent table. Create parent table DAPT1. Okay, how to create? Create table department 1. So here department ID number of 2 and it should be primary key constraint PK DID under the table DAPT1 primary key. Next department name varchar 2 of 14. So it should be some not null constraint, whatever it is, and department address or otherwise department location. It is like varchar 2 of 20. Finish. 3 columns only, but you are creating this table under cluster. So specify cluster. Cluster name EMP-DAPT. Common column name department ID. Take this table and create under the specified cluster. Table created. Insert parent records. At least 2 records I want to insert. Insert into DAPT1 values. What are the values? Department ID 11, department name production, and department location is India. One row created. The next record is 22, and here Sales department, that is also India. Next department is 33 and it is finance department, that is from Hyderabad. 3 records inserted into DEPT1. Now create child table. Create child table EMP1. Create table EMP1 and EID. It's a number of 3 and it should be primary key. Constraint PKEID. What is the table name? EMP1. It should be primary key. E-name. It's like varchar 2 of 10. And salary. This is like number of 6. And last one, the employee related to which department? Department ID. It's a number of 2. And I want to define a foreign key. Constraint FK department ID EMP1 foreign key on which column? DID references from which table? Department 1 table, department ID column. And see, I am creating this child table in the same cluster. Cluster EMPDEPT department ID. Employee table created. Now you can insert employees. Insert all into EMP1 values. Employee ID 111 or otherwise employee ID 1. Employee name A. Employee salary 34,000 and employee department 11. First record. Next, second record. Employee ID 2. Employee name B. Employee salary 24,000. Department number 22. And again, so you know this process, same common process. And C, okay, CV, his salary is 40,000 and he is also working under 22 department. 4 and here Vicky and same salary working under 11 and again 5 so his salary is 41,000 working under same 11 department. 6th record and his salary 50,000 and working under 33. So let me take up to 6 records. At last select star from dual. To insert multiple records we will follow this method. Total 6 records inserted. See, we created cluster successfully here based on department ID column. On that we created index. This is index creation. This is called as a clustered index. Why? Because you are creating index on cluster. Now you are creating parent table DEPT1 under the cluster EMP DEPT. Records inserted and after that you are creating child table EMP1 under the same cluster. So employee table data, department table data stored under one storage area. benefit is in future if you write join query on EMP and DEPT, then the join query will be executed as much as fast since related data is available at one place. So this is the internal performance purpose. How to delete a cluster? If you want to delete a cluster, you can use the command drop cluster name. Drop cluster name. And suppose if the cluster is don't have any tables, then cluster is deleted simply. In case cluster is having tables, then you need to do this. Cluster is having tables, you should use drop cluster name. You have to use including tables keyword. Okay, how to get cluster information? Select star from user underscore clusters. Select star from user underscore clusters. Then it will display clusters information. So this is about clusters. Now we have a small concept. Let me go back to our training. Before going to continue, there should be one concept here. Yeah, I think we did not discuss about the merge statement. What is merge? See, merge is a statement to perform update and insert operations parallelly. To perform update and insert operations parallelly. So how it is? Simple. Listen carefully. You have a mobile. Listen carefully. You have a mobile. Generally, we can boot our mobile by adding our Gmail account. Then, if we switch on sync operation, if you have some image in the mobile that is synced with your Google account. Okay. Similarly, suppose you have one image. You are making changes to the image. That changes automatically reflected into Google account. In case after some days, you are adding one image, new image. First image as it is, and you are adding a new image. Then the new image is inserted into your Google account. What is the difference between first action and second action? If you make changes to the existing data, the existing data should be updated. If you are entering new data, the new data will be inserted. Okay, so at a time, if you want to perform update and insert operations according to your old data and new data, we will use merge statement. The process of updating and inserting parallelly is called as synchronizing your data. See, this is the syntax of merge statement. Syntax of merge. Merge into target table using, this is source table. See, I want to synchronize data into this table, target table, merging into, synchronizing it to this table. Based on which data you are synchronizing? By using, this is the data from a table, data from a view, or data from a subquery. Based on this data, I will merge that data into target table. On which basis you are merging? On match condition. See, target table having the same data, source table also having same data. If both are matched, then we can do like this. When matched, then either you can update your data or you can delete your data. In case not matched, source data and target data not matched, then you can perform insert operation. Again, I am repeating, you are doing merge operation into this table by using this source data. The source data coming from either table or view or result of your subquery. On which basis you are doing merge operation? On the matching condition. In case matching condition is matched, then you can perform update operation or delete operation. In case the data, source data and target data are not matched, then you can do insert operation. Here I have a small example. We have a table student ID, student name, score. Okay, let me create the table, then you can understand. It's easy to understand. Let me create. Before creating student, drop table student if it was existed, and purge table student. Let me paste it. Table created, and let me insert records into student. One row created. The next, total 3 records created. Let me create another table, results. Let us assume student table is March month table, and the results, they are appearing for betterment. Betterment means for the improvement of their marks, they are writing exams again. That recent examination results are from this table. Let me copy it and let me create this table also. Okay, commit and remove. Select star from student. This is original table. And similarly, select star from results. This is recent data. So if any new student is appeared for the second time, the new student information should be inserted into student table. In case old student is reappearing the examination, the old student old score replaced with new score. See, student table, result table. So 111 here, check here. 444, we don't have match. If we don't have match, the record will be inserted. 222, record already matched. Then same name, but here 620 old score. New score 910. So 910 is replacing 610, 620. 333, again matched. So this 333 record updated with these two details. Name updated with Vivek Oberoi, score updated with 840. How can I do that? Merge into student table. You are merging result data into student table. This is alias name, student table alias name A, using selecting data from result. Its alias name is B. Based on which criteria you are merging the data? On A dot student ID is equal to B dot student ID. If both IDs are matched, when matched, then update student table name with the name of table B. So A dot student name is equal to B dot student name, comma, A dot score is equal to B dot score. Okay, and remember, after update, don't write any table name. Into which updation, into which table, it is indicated by alias names here. So don't write any table name. If you write any table name, it will display error. Next, when not matched, then insert into these columns. Don't use into, don't use table name. Why? Because A indicates into which table, column name indicates into which column. Okay, insert A dot student ID, A dot S name, A dot score into these places. Values. So from this table, these values are inserted into these places in this table. After insert, don't use into and table name. After update, don't use table name. So let me execute merge command. In the middle of the statement, don't use semicolon. Only at the end of the statement use semicolon. It is saying 3 rows merged. If 3 rows are merged, then select star from student. Actually, we have 3 students, but now we have student, I think 4 students, and Arya score is updated as 910. Vivek is changed as Vivek Oberoi, and Vivek score 750 is changed as 840. Go through this video, you can easily understand. This is about merge statement. So what is the use of merging? Synchronizing a table data with the data of other table, which is called as merge operation. Tomorrow we have the session. Tomorrow we are going to discuss about synonyms. Synonyms completed, I think not completed. Synonyms, after that we will start functions. So once we finish functions, the SQL part will be completed. Functions will take 2-3 days. Sequence is already completed, Vijay. At the whenever we discussing about constraints, see domain and referential constraints. Domain and referential constraints, here we discussed sequences. Here, see, yeah, sequences and how to use sequence as a default value in Oracle 12c, that we completed. Okay, that's all for today. Rest of the part we will continue tomorrow. Thank you all of you. See you tomorrow.